Hello everyone, welcome to the equation mug. Today we will be doing another arithmetic problem. So let's start with the question. Today's question is a proof, so we will be proving if something is true or false, and it focuses on a method named Vieta Jumping. So today's question is, let a and b be positive integers such that ab plus 1 divides a squared plus b squared. Prove that a squared plus b squared divided by ab plus 1 is the perfect square of an integer. I'll give you guys some time to do this question. So k is this value that we just mentioned, and we can say that k is equal to g squared or any number squared because it is a perfect square. However, let's say that k is not a perfect square. We will be doing this so that we can use proof by contradiction. So let's say that a comma b is a solution to this equation, and that the sum a plus b is the minimum sum of zeros of this equation. We can also assume that a is greater than or equal to b. So let's say that x is equal to a is one of the solutions to k, and we can then replace every single value of a with x, and then we can rearrange the equation into this form: x squared minus kbx plus b squared minus k. From here, we will be using Vieta's formulas. So from Vieta's formulas, we can find the sum of the zeros and the product of the zeros. From that, we can get that x2 is equal to b squared minus k over a, and x2 is equal to kb minus a. Since k, b, and a are all integers, we also know that the x's are integers because of this. So let's take this one possible x value and let's make it equal to 0. If we multiply both sides by a, we can get rid of the a, and we can rearrange it to get that k is equal to b squared, which means that k is a perfect square. This contradicts our original assumption that k is not a perfect square, which means that x2 cannot equal 0. So now let's check for when x2 is not positive and b is greater than or equal to 1. We have this equation: x2 squared minus kbx2 plus b squared minus k is equal to 0. Then we can move the kbx2 to the other side and get the second equation that is on your screen. Now if we plug in our original parameters, we see that kbx2 will have to be negative if we follow that. This means that the left side of the equation is also negative. And this will prove that x2 is a positive integer. So now we have that this is the main zero. We can ignore every single other x2 that we have had in other cases. We can then get this inequality: x2 is equal to b squared minus k over a is less than a squared minus k over a is less than a. This means that x2 is less than a, and the bottom inequality is possible. The bottom inequality states that x2 plus b is less than a plus b, which was our original minimum sum. Therefore, we have proven that a plus b is not the minimum sum, and we have also proven that k is not a perfect square. The assumption that we made is false because k is a perfect square. We have now proved that a squared plus b squared over ab plus 1 equals k is a perfect square. Our original question was, let a and b be positive integers such that ab plus 1 divides a squared plus b squared. Prove that a squared plus b squared over ab plus 1 is the perfect square of an integer. In this video, we have just proved that a squared plus b squared over ab plus 1 is the perfect square of an integer. Thank you for watching this video, and make sure to like and subscribe.